has distinctive elements. And perhaps one of the reasons why you're hearing us talk about this today is because of two groups, the McDonough-Braungart Design Collective doing Cradle to Cradle, and more recently, the Ellen MacArthur Foundation, which has taken some of these ideas and done a very good job of disseminating them. And that's a lot of why they are in contemporary discussion. They have some differences, some evolution, but in fact the core ideas of looking to nature for efficient cycling of resources is one that has been around for a while, but of course only partially adopted. So this oddly named field that I work in, I think the simplest description is to say that it is the science that undergirds the circular economy. Put it another way, my fields are in my field, it's all the nerds who do the numbers in the science. And I owe this conceptualization to my good colleague, Professor Chertow from Yale. So the funny name, this oxymoron, the industrial part is that it focuses on design and manufacturing, and it looks to businesses as agents for environmental change. And the ecology and industrial ecology places human activity in the context of the larger natural system, seeing it, as Ken said, as part of it, not separate from it. And again, back to this ecological analogy, it looks to natural systems for possible models for industrial activity. So the field has a lot of analytical tools as well as some of the concepts you've already heard. The familiar tool of life cycle assessment, lots of carbon footprinting, tracing the flows and stocks of materials through economies, eco-parks, design for environment. So it's a field that focuses on analysis in many ways. So, is the circular economy just recycling with another name? Now I'm going to show you a diagram that you have already seen. This is the famous butterfly diagram based in part on Cradle to Cradle and adapted by the Ellen MacArthur Foundation. So you've already learned about the technical nutrients and the biological nutrients, and if you look at these cycles going up the right side and the left side, you have, in a more elaborated form, basically the 3 R's. But I would suggest that, in fact, the circular economy is really more than just reduce, recycle, reduce, reuse, recycle. That it has, as Ken pointed out, both the notion of different kinds of materials, and it has, very interestingly, this notion of cascades, which is not showing up on my slide there, which also has existed before but has been elaborated in more detail. So to say more about this, the circular economy has some central ideas. One is that the circles should be tighter. That is, it prioritizes, in a simple way, reuse over recycling. It looks to longer cycling, that is greater product durability, but also maintaining those materials and substances in cycles, as Ken mentioned, and then cascading uses, capturing value so that you have a use and then you have another use that may not have the same amount of value, but you continue down extracting the maximum amount of value before the material is released into the environment. And then, interestingly, pure cycles, which is a fancy way of saying an absence of contamination that would undermine these other approaches. And what it does is it highlights upstream design. That is, it's not just about what you do with products and materials when you're done with them, that there's a key element here for designers, for manufacturers, and for the whole supply chain. And it looks to service over products. So let's talk about where this fits in with business. Actually, why bother? Well, the answers are actually obvious. There's public and governmental pressure, there's supply security, competitive advantage, and of course, the actual need to attend to these problems. I'm going to talk about competitive advantage. if the slide will change. So I look to the great philosopher Kermit here, asking about whether it's easy to be green. And I think it's very important. So there's a long-standing argument. You've got people in industry, you've got environmentalists who say it always pays to be green, and you've got industrialists who say, no, 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 it does not pay to be green. And I would say, no, neither are right. What's true is that it depends on the circumstances facing the company and the strategy that it has chosen. And similarly, nor is circular always green. So, to summarize, under what circumstances do particular kinds of environmental investments deliver benefits to shareholders? Will the investments reduce risks for the company? Will it reduce costs? Will it deliver positive returns? There are a variety of ways that an environmental strategy can lead to competitive advantage. So it can obviously reduce costs. There are well-known reputational benefits. There's product differentiation. In a more political sense, there's the opportunity to preempt regulation. And it can also be a source of innovation and changing of markets. The last item on my list here, raising rivals' costs, is a little less self-evident. That's the idea that a company develops an innovation that its competitors do not have, and then the company is able to make a certain approach mandatory in a market, thereby raising its competitors' costs and staying in the market. One example might be a company that's very good at being circular in all the various ways. The slides are getting ahead of me, excuse me. And so what it does is it's able to get some kind of certification for circularity put in place so that its rivals, its competitors that are not good at this, incur costs that it is better in carrying. All right, here's an example of two things. Well, three things. The design element, the cost-saving element, and third, the need for pure materials. This is a problem that has emerged with PET bottles. They are the familiar water and soft drink bottles. In many markets now, we're seeing what are called full wrap sleeves around the bottles. And this is posing a lot of problems for the recyclers who recycle PET bottles. Those labels do a variety of things. They're made out of a material that doesn't fit with the recycling systems that separate the different materials based on density, because they're not made out of PET. The inks can bleed at certain points, lowering the value of the clear PET, and the sorting systems in Europe and the US rely on certain kinds of optical recognition of the resin, and because the sleeve covers the whole bottle, they don't work. And so it dramatically lowers the market value of the recyclate that is produced from these processes. So this is a place where purer circles are needed. So here's the question of what you can call the functional economy, products to services, product service systems. Everybody's got a label. But the eternal question here is, what is it that we're looking for? When it's time to drink a beer, do we want a cold beer or do we want a refrigerator? We want the service, not the physical artifact. This actually has real implications in the market. Here's a company that's become well known. It is a car sharing service called Zipcar. It's the dominant one in the US market that I know of. This is a way of avoiding car ownership. So what the consumers join Zipcar and they get access to the car in a very oversimplified way. You could say it's having access to a car that's longer than a taxi and shorter than renting. And it has transformed the car rental market in the United States, and it also means that we need fewer cars per person, so there's less production of cars. Okay, here is a kind of circularity at a broader scale. This is an iconic industrial district in a town called Kalundborg, 100 kilometers west of Copenhagen in Denmark. And in the early 60s, let me get my pointer here, some of the facilities, the core of this is an oil refinery and a power plant. And they found that they did not have access to sufficient groundwater for their processes, so they collaborated on building a water network to get surface water from Lake Tiso. And a series of resource cascades or exchanges emerged. So for example, the sludge from the air pollution control in the combustion plant was used as, where is it? Right here. It was used to produce wallboard because flue gas desulfurization sludge, that is air pollution sludge, is actually gypsum. This network grew over time. So here we're talking about the period in the 60s and 70s, and then more exchanges occurred, and then you get to the 2000s, come on, actually the 1990s. Maybe we'll get to them. There we go. You see a very dense network emerging. Lots of exchanges and cascades of water, for example, boiler water and circular and cooling water. You have nickel being extracted from the fly ash from the power plant. And then even now, in this century, you see an incredibly dense network of circular activities, with both the attendant reduction in environmental impacts and resource savings, and all these exchanges are done on a profit-making basis. Here's another one that you've seen today. So let's go back to British sugar. So why am I also showing you this? Well, the journal that I edit published the article that Steve Evans' students wrote about this. And I didn't know Steve was going to talk about it. But there's more to be said here. If you take it from the business perspective, why did this all happen? I'm not sure how to make this go back, but we'll give it a try. There we go. So the British Sugar was the largest British sugar producer in the UK, and it got acquired by another food producer. And the new owners said, we want to see more profit and more business development. They couldn't really expand their sugar output because of trade and industrial quotas on their sugar production. So they had to look to other products as a way of expanding the business. Now, historically, they had done things that other sugar beet users had done, which is they captured the dirt and rocks that came in with the sugar beets, and they produced topsoil and stones for construction. But they also then went on to do other things. They built a combined heat and power plant here, and with the excess waste heat from this and from the processing of the sugar itself, they had waste heat that made tomato growing economically effective, and they became the largest producer of salad tomatoes in the UK. They went on to develop bioethanol production, in part based on their sugar production, and then branched outside the company to partner with, around wheat-based bioethanol production. So they have this incredible array of co-product and byproduct uses, to the point where approximately 25% of the income of this company comes not from its sugar, but from its byproducts. So in business terms, what you see is that they started early on looking at basic cost reduction and efficiency improvements. And this, in a certain sense, got them comfortable with looking for those opportunities, and they moved to looking at waste as a source of value. And then as they continued to mature, they started to look at it as a source of innovation. All right, let me stop here. I can talk forever, but I would be glad to take any kind of questions that you have about the circular economy and how it fits with competitive strategy or industrial ecology. Thank you.